Hi everyone, I'm Sano from Yahoo Japan, and I'll be speaking today on the topic of secure DevOps practices here at Yahoo. First of all, let me introduce myself. I'm currently working in a platform-related department in the Cloud Platform division. I joined Yahoo back in 2008, and I was in charge of developing news media and calendar PIM application services. In 2017, I was put in charge of promoting and operating the internal Platform as a Service Cloud Foundry and the Kubernetes platform, or Containers as a Service. And in 2009, I started promoting and operating the internal monitoring observability products, logs, metrics, and tracing. Today, I would like to talk to you about security. The agenda goes something like this. Firstly, I'd like to give you a brief introduction to Yahoo. I'll then take you through today's discussion of container security. So let's start with that brief introduction of Yahoo. Yahoo Japan offer over 100 services. There are many different types. We're a company that provides what I call a cross-section of services. That could be news, media, e-commerce, or auctions, and recently we've been working hard on PayPay. So we are providing a cross-section of services. As for number of users, we're serving both smartphone devices and computers. Currently, smartphones are by far the most popular, with an average of 56 billion page views per month, and more than 60 million monthly active users, making it a fairly large service with a large number of users. The number of engineers in our company is also quite large. We have about 3,000 engineers, which I think is a very large number for Japan. There are two types of engineers. Service development engineers deliver services such as news and shopping to customers, as I mentioned earlier. The other type of engineer is a platform development engineer who develops and operates a common platform for developing services, such as databases and security. The ratio of the number of people involved is roughly 2:1, and I work on the platform development engineer side. So, what are we currently working on? In addition to providing services in the form of business development, we're also doing something called Modernization. We have been using the same kind of technology since the company's inception, but we are undergoing a large-scale modernization process with the goal of making our services more competitive. At the other end of the spectrum, there are efforts underway to move away from the old legacy systems and get a small new force in place. As I'm sure you're aware, we're rolling out Kubernetes on a large scale in the midst of this modernization process. Internally, we provide Kubernetes clusters in the form of containers as a service to internal users. The number of clusters? More than 700 clusters. The number of nodes? More than 18,000 nodes. The number of containers is 160,000 or more. This is quite a large scale. That ends this brief introduction to Yahoo. So let's continue by talking about where we're going with container security. As I mentioned earlier, we have a large-scale deployment of Kubernetes in our company, but we didn't think it was secure enough. I'm going to talk about the process for what's next. First of all, as a matter of course, the goal is to provide secure services by preventing cyber attacks and unauthorized access by introducing appropriate security measures for the container environment. If the service is not secure, no one will use it and it will not be competitive. Therefore, we have been working on this project to achieve this. However, we have a longer history of using bare metal and virtual machines than we do with Kubernetes. So, although we have knowledge about security in that area, we had to figure out how to deal with Kubernetes security. so we did some research. When we looked at what the policy should be, we decided to go with two policies. The first, to comply with external standards. This was provided by an organization called NIST in the form of SP 800-190. It describes the threats and recommendations for container environments. On the other hand, our in-house security experts had developed a proposed approach, but it did not incorporate any of these external standards. This time, we decided to proceed with a policy that incorporated external standards. The other policy is to take into account the productivity of developers. It's a matter of course, but increasing security often results in a decrease in developer productivity. However, we have decided to increase security as much as possible without decreasing developer productivity. These two policies are what we've been working on. There are 5 major risks in the container environment as described in NIST. First, in the top left corner, there is the risk that a malicious user may enter the container from the outside. Also, since containers are running on top of the host's operating system, there is a possibility that a vulnerability in the host's operating system can be exploited. Secondly, in the case of Kubernetes, there is a risk of orchestrator. If the configuration of Kubernetes orchestrator is wrong, there is a risk of hijacking. There is also the risk of vulnerabilities being exposed in the image of the application on the related platform system, and the risk of the registry itself being compromised. These 5 major risks are described in NIST SP 800-190. Let's talk about the scope of this execution environment. This is the CI/CD pipeline in terms of how the application is developed. We use CI/CD tools to build the image from the source code repository and deploy it to the execution environment. In each phase, you need to create a secure application. In the CI/CD tool phase, you check the container image for vulnerabilities. Periodically check the image for vulnerabilities, even after it has been added to the image repository. The execution environment is the most important thing. Even if the container is running, check for vulnerabilities and configuration checks to make sure that the root privileges are not stolen due to unnecessary configurations in Kubernetes or Docker. Another thing is that even if someone has been breached, you need to deal with them appropriately by finding out their malicious behavior. Lastly, an audit of the operation log is the last step. If something goes wrong, it should be able to be looked at in the past. These 4 things are so important that we decided to prepare for these requirements by either building our own container security mechanism or buying one. First of all, we have created a workflow image. As far as behavioral detection is concerned, we'll be constantly monitoring it in the SOC on the right. The policy settings for that are deployed to Kubernetes through the security mechanism. We'll also send logs and alerts to Splunk Enterprise Security for analysis. If it's a problem, we'll register it with a ticket management system like Jira. We then allow our engineers and Kubernetes Container as a Service engineers to take care of it. The SOC team should also be able to produce regular security reports to work with the manager as well. Next, let's talk about the configuration check. Configuration checking is mainly a mechanism to check if Kubernetes has been improperly configured. Here, the Containers as a Service administrator creates a policy for the configuration itself. If there's an incorrect configuration, we've come up with a mechanism to notify the engineers. And then we were trying to figure out a way for a report to be generated to the SOC team as well and reported to the file manager as a security report. Finally, vulnerability detection. If a vulnerability exists in a running container, engineers are notified. The engineer will then take action. The CSIRT team sets and monitors the policy for vulnerability detection. They then work with managers through security reports to increase the overall level of checking. Next, let's talk about the process of selecting a container security product. I'll talk about how we selected our product to meet the requirements I mentioned. There is something called the CIS Benchmark, which is a best practice for security settings published by an organization called CIS. It specifically defines what is compliant with NIST SB 800-190. Among the 4 requirements that we talked about earlier, in the case of vulnerability checking, vulnerable packages should not be mixed in. Also, if it's behavioral detection, it could be something like looking at the audit logs and checking immediately when the OS is breached. However, it was not clear what the configuration check should be done. After some research, we found that the CIS benchmarks specifically describe it. So we decided to do a configuration check using this benchmark first. Here is a link to a specific description of those benchmarks. First, we did this CIS benchmark in-house, and the Kubernetes CIS benchmark has specific descriptions of how to do it. It also includes commands to check. For example, it describes how to look at file permissions or how this particular setting is a bad setting amongst certain settings. We tried to script it ourselves and run it, and when we actually did that, we found out there were over 110 items, which is a lot. And it was difficult to distinguish whether each item is correct or not. Kubernetes is upgraded every 3 months. Therefore, every time Kubernetes is upgraded, each and every time, we would need to do a follow-up check on the configuration criteria. If we could build CIS Benchmark, we will build vulnerability detection and behavior detection system by ourselves. As a result, we decided to consider a commercial product. Let me talk about how we went about selecting a commercial product. First, we went on a trip to the west coast of the US to look for container security products with the security and platform people. Then, we listened to product introductions and demos to see what the strengths of each product were. After returning to Japan, we compared the functions of the 5 companies' products. And, after conducting a proof of concept with 2 companies, we selected one of them and decided to implement it in-house. This is a comparison of 5 companies. I'm not going to go into too much detail, but we compared Company A to Company E in terms of behavioral detection, vulnerability checks, configuration checks, and audit logs. The results showed that Company A and Company B had a good rating, so we asked those to do a proof of concept. That took about 3 months for each company. Finally, we selected Company B based on the results of the proof of concept. In fact, we actually did a more detailed evaluation of the functional aspects and implementation of the system than this. This is just a summary. We would have preferred to go with Company A if the results of the proof of concept were good, but we confirmed that Company A did not have enough functionality, and so decided to go with Company B. Company B is Sysdig, and a product called Sysdig Secure. Originally, Sysdig had a product called Sysdig Monitor. Sysdig Secure is a product that is mainly for container security. Later on, Sysdig also participated in a CNCF project called Falco. As a result, we decided on Sysdig Secure because it's the most in line with UI and our thinking. Now that we've decided on a product, let's talk through the internal implementation. Next, I'll talk about how we proceeded with the internal implementation. This is how we went about the steps to the production deployment. Firstly, we created a structure. We did a proof of concept, but we also made sure that it would be a functional fit for the more detailed business processes we had in mind. We had a phase where we checked whether we needed to make any changes to the workflow. Then, in preparation for the deployment to the production environment, we deployed the system to some of the services as a pilot and identified some issues. Finally, we built the production environment and implemented it in stages. We decided to deploy the system in stages because there is a risk of not knowing what will happen if we introduce it all at once. The structure has been set up this way. The Yahoo team is the security and platform. Security is the SOC and CSIRT teams. There will be more on the roles of the SOC and CSIRT teams later. Sysdig Admin is the team that leads the infrastructure part of Sysdig. The Container as a Service team is the Kubernetes team, which is deployed on a large scale internally. Sysdig also has employees in Japan as well. They have assigned a technical account manager to the team. We also had a Japanese senior architect of sorts assigned to us. In addition, they work closely with the US product manager, and we were able to create a system that allowed them to respond quickly to our requests. The role of SOC is to monitor the occurrence and signs of security incidents. The role of this project is to create a process to understand and respond to behavior detection. We have also defined the policies and criteria for behavioral detection. The rest of the process requires alerts and analysis. To begin with, defining a policy is not something that can be easily converged. Therefore, we need to improve the policy while actually operating it. Regular audit reporting will also be done. The SOC's main role was to find something. The CSIRT's role is to minimize when some security incidents occur. But when it comes to vulnerabilities, they also do things like diagnose and take preventative measures. The CSIRT is the team responsible for vulnerability management. This team also defines the business process for responding to vulnerabilities and the policies for understanding vulnerabilities. They also create continuous improvements and regular vulnerability reports, as false positives in vulnerability identification may also occur. Lastly, we have Sysdig Admin, the team responsible for building and running the Sysdig cluster inside the company. At the beginning, we had 1 or 2 members. At present, we have gradually increased that number of members to 4. Their main responsibilities include building and upgrading Sysdig clusters, integrating with external platforms, monitoring Sysdig, and deploying Sysdig agents. Next, let's talk about the actual configuration. The configuration looks like this. The production network and secure network on the left is Yahoo's network. On the production network, we have a Kubernetes CaaS environment. There are multiple Kubernetes environments with this CaaS environment. Each Kubernetes node has a Sysdig agent deployed on it, and the Sysdig agent sends data to the Sysdig clusters. The Sysdig cluster is also deployed in a CaaS Kubernetes environment, where the Sysdig cluster receives information from the Sysdig agent and performs security checks. There is a proxy in the top right corner. Watchtower is Sysdig's SaaS monitoring mechanism, which gets its vulnerability information from the vulnerability database. Later on, we also use Splunk internally, which sends information from the Sysdig cluster to Splunk to take advantage of the security features inside Splunk. So when Sysdig does a behavior detection, they can see what commands, etc., were executed and what they did in 15 seconds, before and after, in detail. It can all be acquired as capture data. Capture data can be examined in detail because the information is taken from the system calls. However, there is a possibility that sensitive information may be included in the capture data. Yahoo's data centers are located in the east and west regions of Japan. The two networks shown in this figure are located in the east and west regions of Japan. The other two are the development environment networks. There are 3 identical configurations in total. Next, let's talk about how we built our test environment. The first thing we did was set up a CaaS environment. Then, for our first Sysdig deployment, we had 2 engineers from Sysdig in the US come to Japan to provide strong support for the deployment. As a result, the Sysdig admin and Sysdig teams were able to deploy the Sysdig cluster in just 2 days. This was very good. Later on, our internal CaaS Kubernetes environment, which we use internally, had special specifications that required some adjustments to deploy the Sysdig clusters. However, the US Sysdig engineer solved that problem for us. Now that the test environment was built, we used the test environment to check the business flow and functionality in detail. The biggest gap was the WebUI and RBAC. Initially, we were not able to implement detailed permission management. Originally, only users and administrators were allowed to manage permissions in Sysdig. SOCs were required to view and configure policies, and CSIRTs were required to view and configure vulnerabilities. Also, CSIRTs need to view and configure vulnerability policies, and Sysdig does not allow for these role-based permissions. Because it was difficult to adapt our workflow to Sysdig, we requested the RBAC specification to Sysdig. We then worked with Sysdig to discuss the specification. As a result, Sysdig developed features for RBAC and closed the gap. Later, for the WebUI, Sysdig allowed us to restrict viewing on a per team and per service basis. I'd like to explain what exactly we've been able to do. Here's an image of the Kubernetes cluster. There is a Kubernetes cluster called News and a Kubernetes cluster called Shopping. And here's a Kubernetes cluster called Shopping. In this case, the person in charge of News only wants to see the vulnerabilities in the News Kubernetes cluster. But the original Sysdig feature allowed for vulnerabilities in all clusters to be viewed. Therefore, the News staff had to filter out the vulnerabilities in the News cluster only if they wanted to see them. After consulting with Sysdig, Sysdig developed that the News team was able to use the concept of a team to filter out vulnerabilities in the News cluster automatically. As I mentioned briefly, we actually spent a lot of time painstakingly working on this initiative. Here is the actual WebUI of the vulnerability information. It's mostly internal information, so it's almost a mosaic. You can't see almost all of them, but the list on the left is the list of service clusters. In this UI, you can see all clusters because you are logged in as an administrator. The administrator should be able to see all the vulnerabilities in this way, and if the person in charge of News logs in, only the vulnerabilities of the News cluster are visible. Now that we have this feature, we are ready to apply it in production. Next, we did a pilot with the production service. A pilot is an effort to try out some of the services before rolling them out across the company, now that we've made some preparations. During the pilot, we actually encountered an issue with the amount of memory used by Sysdig Agent. We found that our internal Kubernetes environment was optimized for resource utilization and limited the amount of memory. In the test environment, the amount of memory was not limited. However, in a service using 100 nodes, the amount of memory used by the Sysdig Agent became too much. So we had to significantly reduce the amount of memory used by the Sysdig Agent. We had discussions with Sysdig to resolve this issue. Gradually, we made adjustments, and as a result, Sysdig was able to significantly reduce the amount of memory used. Next, we'll talk about integration with our internal platform. By seamlessly integrating our internal platform with Sysdig, we made it easier for our developers to log into the WebUI. Specifically, we synchronized employee master data and Sysdig accounts, and the service master data contains information about the person responsible for the service. We tied this information to the Kubernetes cluster. The result is that the services rep can now view information for his or her service only in the WebUI, and the Splunk integration provided a mechanism for getting the data into Splunk. And we used Active Directory to achieve SAML integration. Initially, the Sysdig admin team was 2 people. We are now 4 because we were short on resources with just 2 people. However, the team has found it necessary to work on automation as well. We are now making considerable progress with automation. Building and upgrading Sysdig clusters is now almost a one-click process. We are automating the integration of employee and service information. Behavior detection policies need to be continuously changed. That's why we use internal Git. In that Git, we process policy pulls and requests, and the policies can be deployed automatically. We also have some intermediate components, such as proxy, and those components are also deployed automatically. The automation allows us to take as much of the load off the infrastructure operations as possible. I'm talking about the other challenges that arose. We had the challenge of very high IOPS to storage. If this issue could not be resolved, we would not be able to release to production. We had a lot of things going on, but we were able to resolve this issue just yesterday. As a result, we were able to proceed with the release to the production environment. It took quite a bit of time, but we were able to resolve it. The other issue we faced was the low number of Sysdig agents we could manage per Sysdig backend cluster. Originally, this requirement was 2,500 nodes per cluster. Currently, we have 18,000 nodes. In the future, the number of nodes will increase further. Since there are only 4 Sysdig administrators, this would increase the operational load considerably. Therefore, we asked Sysdig to increase the number of Sysdig agents that could be managed per Sysdig backend cluster. As a result, we were able to achieve 10,000 Sysdig agents per Sysdig backend cluster. It's a simplified explanation, but we were actually able to achieve this result after much discussion with Sysdig. We figured that with this, we would be able to deploy to the production environment with peace of mind. Now let's talk about the current situation and future plans. We have not yet deployed it to a production environment, but we do plan on proceeding with the deployment to the production environment. We have finally completed the deployment of Sysdig Agent in the development environment, and we will be deploying it in the production environment by October. At the same time, our SOC team will begin behavioral detection, and for vulnerability management, we will begin providing a WebUI to service developers in the next month or so. Yahoo Japan implemented Kubernetes as a modernization initiative, and now we have a new initiative for container security. Second, we did a lot of research, did some desk side comparisons and proof of concepts, and selected Sysdig Secure as the best container security product. Third, oftentimes the security team is in the role of directing, and the platform team doesn't want to take direction. In our case, however, we were able to work well together. We were able to execute on our goal of increasing the division of labor and container application security, and set up a secure DevOps environment where our service developers could deploy secure applications. That concludes today's discussion, but I would like to end with something important to share with you. Yahoo Japan is currently looking for a platform engineer. We're looking for people to come and work with us. You can find a QR code here. Also, if you enter your platform in a Yahoo search, you can view it. Thank you for your cooperation. That's all for today's session. Thank you very much.